Okay, here we go, boys and girls. This is the Unit 4 Review 1. Unit 4 Review 1. So let's go ahead and take care of this. This has a lot to do with, obviously, differentiation, implicit differentiation, and all that good stuff. All right, so a guitar string is plucked and it vibrates with a frequency of that, where F is measured in vibrations per second, and tension, capital T, is measured in pounds. Find the rates of change of F when T is equal to 4. So rate of change is just the derivative. Right now, F is equal to 200 T to the 1/2. So the derivative of that is equal to 100 T to the negative 1/2, which is equivalent to the square root of T on the bottom of 100. All right, so that is our basic formula. So what is the F when T is equal to 4? In essence, is the problem, and so that would be 100 divided by 2, and that'd be 50. All right, so this is a derivative with respect to T. So it's in essence df dt. So the numerator of this is whatever F is, and that's vibrations per second. Just a little bit smaller, so I have some room to write here. All right. So as I said, the F on the top is vibrations per second. And the denominator is T, which is pounds. Okay. That is what the label is. First problem. All right, so that's that dude right there. And then So Nice play it twice with 9. And so with 9, that would make the denominator 3. So that's 100 over 3, or in other words, 33.33333. And again, that's vibrations per second per pound. And that's that dude right there. Exercise 29 and 30, use the position function for a free-falling object, so that V naught and S naught are the initial velocity and initial position. A ball is thrown straight down from the top of a 600-foot building with an initial velocity of negative 30 feet per second. All right, so the first question is determine the position and the velocity function. So the position function is that S of t, which is negative 16 t squared, plus the initial velocity, which is negative 30 t, plus the initial position, which is at top of the 600-foot building. So that is the initial position function, and then the initial velocity, or the velocity is the derivative of that. So that's negative 32t minus 30. Okay, so that is position and velocity. Determine the average velocity. Okay, so again, when we're talking about average velocity, the average velocity, it's change in position over change in time. And again, this is going to be like the slope formula. So this is going to be S of 3 minus the position at 1. So the change in position over change in time. So it's like a normal slope equation. So I am going to plug this into my calculator. So I'm going to go store 3 as x and put it into the position. So negative 16x squared minus 30x plus 600. So that's 366 minus the position at 1. So 1 store x. Second enter, second enter. The position is 554. The denominator is 2. So putting this all together, that's 366 minus 554. Get that answer and then divide by 2. And this is going to be negative 94. Negative 94 is the average velocity from 1 to 3. And since that's a velocity, that would be feet per second. Velocity is change in position over change in time. So change in position is the change in s. What is the instantaneous velocities at t1, t3? So instantaneous velocities are the velocity equations. So what is the velocity at 1 and what is the velocity at 3? These are going to be our instantaneous velocities. So at 1, so again, make sure your 1 is stored as x and use the velocity. So that's negative 32t minus 30. Again, this is a velocity, so that's feet per second. Same question, but with 3. So I store 3 as my x, and second enter, negative 126. Those are those two velocities. What is the time required for the ball to reach the ground? That's when position is equal to 0. That's when position is equal to 0. So that would be when the position is equal to 0. You might be able to factor that. I doubt it, but you might be able to factor that. I'm just going to use the quadratic formula to help get this answer. So this is negative b plus minus the square root of b squared minus 4ac all over 2a get the outside, inside, bottom. So the outside is going to be 30 plus minus the inside is going to be negative 30 squared. Negative 30 squared minus 4ac. So the inside is going to be 39,300. All over negative 32. I have to take both of them. All right, so I'm going to get a plus answer and a minus answer using my calculator. So my plus answer, my minus answer. And again, I'm not talking about a positive answer and a negative answer. I'm just talking about that plus minus. So the plus answer would be 30 plus the square root of 39300 divided by negative 32. That's negative 7.1326. The This is a time, so that time doesn't make any sense. And then the minus answer is the 30 minus the square root. 2576. Again, these are times, so again, the -7 seconds doesn't make any sense. So my answer would be 5.2576 seconds. Okay. What is the velocity of the ball at that impact? So they want to know what is the instantaneous velocity at that impact. So we're looking at the velocity at 5.2576 seconds. So the velocity at that, so I'm going to just take this, store this as x, and put that into my calculator. -32x minus 30, and so the velocity would be -198.2423. This is feet per second. The velocity of an automobile at rest is blah, 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 where v is measured in feet per second. Find the acceleration at, okay. So the derivative of velocity is acceleration. So if velocity is equal to 90t over 4t plus 10, that would imply that the acceleration is the derivative of that. So bottoms up, derivative of the top. A little bit more room here. Minus, leave the top alone. Derivative of the bottom. All over the bottom squared. So this is 360t plus 900 minus 360t all over OT plus 10 squared, obviously a simplification, and so thus the acceleration is 900 over 4t plus 10 squared. Okay, so that's the acceleration. The derivative of velocity. Okay, so find the acceleration at 1 second. So what is the acceleration at 1 second? So what I'll do is I'll go 1 store x, and this is 900 divided by 4t plus 10 squared. Didn't we get the division in there? There it is. Okay, so 900 divided by 4t plus 10 squared, and that's going to be 4.5918. This is an acceleration, so this is what, feet per second squared. Okay, this is also 225 divided by 49 if you want it that way. Yeah. So at 5 seconds, so I'm going to store that as x, second enter, second enter, second enter. That's straight up 1, so the acceleration at 5 seconds is 1 foot per second squared. The acceleration at 10 seconds, 10 store x, second enter, that's 0.36 feet per second squared. In and that is also, math enter, enter, 9/25. Okay, so real quick, if this were a non-calculator question, like say you're taking the test and this is part of the non-calculator question, and shh, don't tell anybody, but you use your calculator kind of thing. If you're taking the non-calculator portion, absolutely give me the 9/25 answer. I mean, because if I see, oh, I got an answer of 0.36 and it's a non-calculator question, you're cheating, and I know it. So if you're doing a non-calculator, make sure you're given the fraction answers. If you're doing a calculator version, it doesn't really matter. You can give me the decimal, you can give me the fraction. It doesn't really matter. So, all right. All right, so just straight up do this with implicit differentiation, these problems. This first one is a u times a v. So I take the derivative of u, which is the x to the third. So that's 3x squared, leave the second part alone, plus leave the first part alone, derivative of the second. So that's dy dx. Okay, so that is the first one. Now, do the second part. Think of this piece as in its own parentheses. So you kind of ignore that negative sign. You bring that negative sign out. You do the product rule, and then what's going to happen is you will eventually bring this negative sign back in. But without taking it to the outside, a lot of times people forget about the fact that it'll be a negative, and the addition that is going to be created will stay as an addition. Okay, so first part is derivative of x, so that's 1, leave the second part alone, plus leave the first part alone, derivative of the second, so that's 3y squared, and I took a derivative of a y, so that's dy dx. All right, so this is what I was referring to. Like, without creating this parentheses right here, a lot of times people won't make that a minus. All right, so it's very easily to overlook that. So if you create the parentheses, it makes it a little bit more apparent. And then derivative of 4 is 0. All right, so that is our basic derivative. And now all we have to do is isolate the dy dx in the problem. Okay, we isolate the dy dx. So what stays and what goes? So 3x squared y goes, so that's negative 3x squared y. That goes. The x to the third stays. And again, think of this as a minus coming in right here. So the negative y to the third goes, so it'll be a positive y to the third over here. And the negative x 3y squared stays. All right, so what goes and what stays. So I kept all the dy dx's, put them together, and then I moved everything else. And now I have everything isolated the way that I want. Thus, dy dx is going to be equal to negative 3x squared y plus y to the third divided by x to the third. Excuse me, this is a minus. Minus 3xy squared, 3xy squared. If you look that up in the book, a trick that you may need to know is this. If you would have, like, pushed all the dy dx's to that way and kept all the numbers on that side, a potential answer that you could have is the exact same answer, but just opposite signs of everything. So this is the same thing as saying 3x squared y minus y to the third over negative x to the third plus 3xy squared. And so it's the same thing. So just be heads up, because I think one of these is on a multiple choice question, or if you're taking a look at the answers of these in the answer key that is in the book, a lot of times you'll see answers that are the exact correct answer, but just everything is an opposite sign, and that's totally fine. All right, derivative of this dude. So the first is the x, so that's 1, leaving the second part alone. Plus, leave the x alone. Derivative of the sine is cosine. Chain rule is dy dx. So that's the first part is equal to the derivative of y is dy dx. Leave the second part alone. Plus, leave the first part alone. Derivative of the second is negative sine x. Chain rule is just a straight up 1. Okay, push all the dy dx's to one side, everything else to the other. I'm going to get all the dy dx's to the right-hand side. So that would leave a positive sine y over here. This negative x cosine y goes to the right-hand side. This is joined forces with the cosine that is already there. And so that, I think that's all the dy dx's that I have. And then this negative sine, etc., comes back over. And so that coming over would be a positive y sine x. All right, so I pushed all the dy dx's to the right-hand side, pushed all the stuff without a dy dx to the left-hand side. My equal signs here. And then I divide out, isolating my dy dx. So this is sine y plus y sine x divided by, I'll just rearrange the order here a little bit, cosine x minus x cosine y. All right, so here we need to find an equation of the normal line and the tangent line and the normal line. They say graphic, don't worry about graphing it, just we don't have enough room to work with. So just go ahead and find the equation of the normal line and the tangent line. All right, so we have a point, all we need is a slope, and a slope is the derivative. So we need to take a derivative of this, and that will help us find the slope of these equations. So derivative, here we go. So the first part is the y ln of x, so the derivative of y is dy dx. Leave the second part alone, plus leave the first part alone. Derivative of the second is 1 over x, plus the y squared, so that's 2y dy dx. That's all equal to 0. All right, so what do I have here? I have ln of x plus 2y, and I have to move the y in the 1 over x, so that's a negative y over x. Divide out, so that leaves dy dx to be equal to negative y divided by x, ln x plus 2y. Alrighty, that is my derivative. So now I need to take this derivative at my point. So I'm taking my derivative at the point e, and that's e to the first power negative 1. And so that would be equal to positive 1 over x. ln of x is 1 plus 2y. So that is a denominator of a negative, so this is negative over e to the first power. Again, there's a lot of writing. I don't know if I provided enough room on the actual worksheet, but this is what it is. Okay, so again, what a derivative is a slope of the tangent. Okay, so let's start with the equation of the tangent. And this equation of the tangent has a point of e to the first power minus 1, and it has a slope of negative 1 over e. So y minus y1 would be plus 1 is equal to m x minus x1. So multiplying this in, this is negative 1 over ex plus 1 on the multiplication. And then the plus 1 that is on the y comes over as a minus 1. And thus y is equal to negative 1 over ex, and the 1's eliminated each other. So that is the equation of the tangent line. And then recall that the normal line is the line perpendicular. So the slope is an opposite reciprocal. So the normal line still has a point of e to the first power negative 1, but this time it's an opposite reciprocal. So it's a positive e over 1, so a positive e to the first power. Thus, the equation now is y minus y1, so that's plus 1, is equal to m x minus x1. So this is ex minus e squared minus 1. And there's your equation of the normal line. Use logarithmic differentiation. I think I kind of melted down a little bit on the last one. I know how to do logarithmic differentiation a lot better now. The idea is this: if what I'm going to do is I'm going to take an ln of both sides. All right, now the thing to notice that if you have an ln of a times b, for instance, an inside multiplication is a natural log of a plus natural log of b. So a multiplication on the inside is an outside addition. Same idea is if I have a divided by b. A division is a subtraction. And last but not least, if you have and I'll say to the second power or some exponent in there, what that is an outside multiple of the ln. And so that's the key to success when you're doing logarithmic differentiation, is just to kind of understand this idea. So again, I am taking the natural log of the original problem of both sides. So there's not a whole lot to do on the left-hand side, but notice all the multiplications and exponents and stuff on the right-hand side. Okay, and that's going to be the key. So this is going to be the ln of y. Let's start this off. So first there's this x. So the ln of x. And then that's being multiplied to this square root. So that's to the 1/2 power. So again, powers drop down as a multiple. And then this is all being divided by, so again, that's going to be a subtraction of the ln of x plus 4. Okay, this is logarithmic differentiation. This is the idea that where we're going to start. All right, so now we're trying to find dy dx. So think of this as an implicit differentiation. All right, so the derivative of an ln, okay, the derivative of an ln is 1 over that, and then don't forget the chain rule, so it'd be times f prime. So that's the idea of a derivative of a ln. So here we go. Here we have 1 over y dy dx equal to 1 over x plus 1/2 1 over x squared plus 1, chain rule is 2x, minus 1 over x plus 4. Okay, so simplification there. And so ultimately dy dx is 1 over x plus x over x squared plus 1 minus 1 over x plus 4. And then to get rid of the 1 divided by y, I multiply by y, so y multiplies all of this. Now I'm pretty happy with that answer right there, especially coming from where we came from. I'm cool with that answer. But here is straight up what the book does to get their answer. Okay, so this is going to be a beast of a common denominator here, but the idea is that you want to get a common denominator. All right, so this far left, I'm referring to the 1 over x, needs a denominator of an x squared plus 1 and a x plus 4. So I'm just going to kind of do that on the side here real quick. X squared plus 1 and an x plus 4. It's going to be x to the third plus 4x squared plus 1x plus 4. Okay, so that's x to the third plus 4x squared plus 1x plus 4. The middle fraction needs an x and an x plus 4. And so it already has a numerator of an x, so that's going to add an x to the third plus a 4x squared. And then last but not least is that third fraction, which needs an x and an x squared plus 1. Okay, its numerator is -1, so this is going to get a negative x to the third minus x. And so that will establish the common denominator of x, x squared plus 1, and then x plus 4. Okay, this all has it outside of a y as such. Oh, gravy. This is nasty. Okay. Simplifying this thing, I have a negative x to the third, a positive x to the third. Negative x, I have a positive x. Yeah. So this is equal to x to the third, x to the third. I just don't want to mess up here real quick. I've come too far. Yeah. X to the third plus 8x squared plus 4 over x squared plus 1 and x plus 4 with an outside y. Right, and I got to there and I'm like, yeah, but then I checked the answer in the book and it was not the same thing. Okay, it's like, I'm like, how the heck did they get their answer to this? Okay. And how did they get their version of the answer? And here is the kicker of the whole thing. Y is equal to this. So what you do, now that you in essence have an answer, is you replace y with its equation. So y gets replaced with x square root of x squared plus 1, and then an x plus 4. Okay, and that is being compared to x squared plus 1, x plus 4 as a denominator of x to the third plus 8x squared plus 4. And then there's just a basic simplification. So this is multiplying. So this top x eliminates this bottom x. Okay, this x plus 4 will join forces with that x plus 4. And then the x squared plus 1. Is it like, in essence, something with a 1/2 power on top and a 1 power on bottom? So what results is the bottom is bigger by a half. So the half remains on bottom. So what will yield from this is this simplifies, and there's just this to the 1/2 power left on that simplification. So the denominator is left to be the square root of x squared plus 1, then x plus 4 squared, because there's one that joined forces, and then the numerator is 8x squared plus 4. And I think that is the answer in the book right there. But again, I am pretty happy with this dude right there. Again, I have yet to see a logarithmic differentiation problem on the actual big test, so I'm not really sweating it. If you do, then it's probably a calculator problem, and you can just type that into your calculator taking the derivative. But I don't think there is a non-calculator question that depends upon logarithmic differentiation. All right. Point moves along curve y such that the y value is increasing at a rate of 2 units per second. So that means I change colors. The y is increasing with respect to time at 2 units per second. What is the rate of x changing at the following values? Okay, so the question is, what is dx dt? Okay, that's what the question is. So right now we have y is equal to the square root of x. And we need to get these with respect to t. So both of these, you have to add the dx or dy dt when you take the derivative. So the derivative of y is 1, so that's dy dt. The derivative of x is 1/2 x to the negative 1/2, and that gives a dx dt in that situation. Making this equal to 2 square root x dx dt. And because I'm solving for dx dt, you don't have to do this step, but I think it's a little bit easier. I'm going to isolate the dx dt, and that would imply multiplying out the 2 square root x. All right, so this is the given information or the information that we can figure out. There isn't any straight up y's, so that's pretty easy. All right, so when x is 1/2, what is the dx dt? So the dx dt in that problem is going to be 2 square root of x dy dt, which is 2. So the square root of 1/2, I'm just going to kind of think on the side here, square root 1, square root 2, 1 over square root 2, which is square root 2 over 2. So if I'm multiplying that with a 2, that like kind of like eliminates that with that, leaving a square root 2 and that second 2 that is there. So this should be equal to 2 units per second, sorry. This is a change in x, so that's units per second. Okay, when it's 1, square root 1, same difference. There's 2, so this is going to be equal to 4. And then when x is 4, so that's 2 square root x times 2, and so that's 8. Multiple choice, no technology. Where's the derivative of that? So dy dx. So dy dx, so this is derivative of x, so you don't have to worry about the derivative of x. You just, whenever you take a y, it's a dy dx. All right, so here we go. 6y squared dy dx minus 3. And now here comes the derivative of x times y. So the derivative of x plus the derivative of y. Again, notice how I create that in its own parentheses. I take out the 3. Plus 2x is equal to 0. Save all the dy dx's, move everything else. So that is 6y squared minus 3x move everything else. So that will be a positive 3y and a negative 2x. Divide out. So dy dx is equal to 3y minus 2x, 6y squared minus 3x. Now, that isn't an answer right now. It's close to option B, but it's not the same. And then if you recall what I mentioned earlier, if this is truly your answer, it is the same thing as flipping all of the signs. So that is like a positive 2x and a negative 3y, a positive 3x and a negative 6y squared, which now is option B. Okay, you can only do this when it's a fraction. Can't do it if it's not a fraction. Volume of the cylinder with radius r, height h is given by blah, blah, blah. The radius of the cylinder is increasing at a rate. Okay, so the radius is increasing. So dr dt is increasing at 1/3 centimeters per second. So increasing, so that's a positive. The height of the cylinder is increasing, so the dh dt is increasing at 1/2 centimeters per second. At what rate is the cubic centimeter? At what rate in cubic centimeters per second is the volume increasing? So the question is, where is the volume increasing at? Question mark. When the height is 9 and the radius is 4. All right. So this is the lay of the land. This is the given information and what the question is asking. All right, so the volume of a cylinder is given by V is equal to pi r squared h. And both the r and the h are changing. So you have to think of it kind of like a u times a v kind of scenario right there. So here we go. Derivative. So derivative with respect to time is equal to pi. The r, so that's 2r. So I'm taking the derivative of r, so that's dr dt, and then times h. So I take the derivative of the first, leave the second alone. Plus, leave the first part alone. Derivative of the second, derivative of h is dh dt. And that's that. All right. So again, we have enough information to plug and chug right now. So let's just go. I know I'm not supposed to use my calculator, but this is just two stupid calculations. So 2r dr is 1/3, so 2r dr times h plus r squared dh. And so this is 32 pi, and this is volume, so that's going to be centimeters cubed per second. Two roads intersect. Two roads intersect. All right, I'm going to take a pause here. I'm going to have to start a second video. I have to start a second video. I have to start a class right now. So for the rest, watch the second video.